we'll move on to the next item in the agenda. And really happy to introduce our next invited speaker, Satya Mallick from Site Commerce. Like I mentioned this morning, one of the things we like to do at these meetings is bring in people who are doing cool end products with vision, because I think it's important to be able to understand how, at the end of the day, how is money being made with vision technology? Because if money is not being made with vision technology, we're not going to be around having these fun meetings very long. The good news is the answer is money is being made lots of ways with vision technology, and that's expanding. And I really like the things that Satya's company has been doing. I think a lot of creativity there in terms of applying vision to real-world problems in ways that are maybe not immediately obvious to the uninitiated. So welcome, Satya. Looking forward to your presentation. Let me give you the microphone.
Thanks, Jeff. So good afternoon, everybody. My name is Satya Mallick, and I'm the VP of Technology at Site Commerce. I'm also one of the co-founders. So what our company does is we are trying to transform the beauty industry with computer vision and machine learning. But before I start this presentation, I'd like to tell you a little story. A few years back, an ex-CEO of a beauty company told me that in 2004, they commissioned a study from McKinsey. And the question they wanted to answer is the internet here to stay? And this was in 2004. So we are talking about an industry that doesn't move very fast as far as technology is concerned. However, we live in a very great time because, as Victor Hugo quoted, nothing is as powerful as an idea whose time has come. And the time is now. The idea is that vision, graphics, and learning is going to transform the beauty and fashion industry. The obvious question you might be asking is, why? Well, if you think about the beauty and fashion industry, shopping is visually inspired in this industry. If you turn the pages of a beauty or fashion magazine, you will see that 50% of the pages are glossy, good-looking pictures. And that's how shopping is inspired. Now, just to give a contrasting way in which Intel sells its product, when you look at how Intel sells... Well, we obviously know how Intel sells its products.
You haven't seen the Rockstar commercial. Or the bunny suits.
Let's see how Victoria's Secret sells its... One compelling picture sells their product. That's it. So in this industry, if we can help them create compelling pictures, we will sell their products. This has to be done economically, obviously. Now, the second thing is that communication has become very, very visual these days. If you look at all the top companies that have a very high valuation, they are either image-related or video-related. Even when they are not image or video-related, let's say WhatsApp, we think about WhatsApp as a texting company. But WhatsApp is responsible for 500 million uploads a day. Out of that 1.8 billion, 500 million comes from WhatsApp, which is a texting app. Now, it's funny because people don't say that I'm really happy these days. And sometimes I feel that, why would you, when you can just put in a smiley? And maybe that image is more compelling than saying that I'm really happy. Needless to say that image data is abundant right now. Like I said, 1.8 billion photos are being uploaded every day, and we don't know what to do with such abundant image data. There is such large amount of data, which is surprising, because back in 2006, I was looking at some slides we presented to VCs, and we said that 23 million photos are being uploaded to the internet every day. And 7 years later, it's 1.8 billion. One other aspect of shopping that has been consistently improved is personalization. So if you go to Amazon today, the entire page, if you're logged in, the entire page is personalized for you. But there is a next step that has not been achieved yet, and that would be based on image-based recommendation. And I'll talk about it a little bit in this presentation as well. So like I said, that we are in a very good position as far as beauty and fashion industry is concerned, even though they are pretty late adopters of technology, because there is this synergy. There are these transformations happening in this world. It's an idea whose time has come. Now, let me give you a brief overview of what we do at Site Commerce as far as computer vision and machine learning is concerned. Our main product is virtual makeover. Well, what is that? Our website, task.com, is one where women can upload their own picture and apply makeup virtually. So you can try makeup before you make a purchasing decision. We also do jewelry try-on, virtual nails, and that affects e-commerce, virtual clothing, product recommendation based on facial analysis, and recently we started doing apparel recommendation as well. So we started this company as a photo enhancement tool. So we wanted, the data we had at that time was 80% of the photos uploaded to the internet are human faces. So why not make an editor that is really good for faces? So on this, in this photo, you can see that, well, here you can't really see, but the gloss on the face has been removed, the colors have been enhanced, the lip color has changed, eye color has changed. And we were pitching this idea to a lot of VCs. And one of them said that, look, a photo prints for 9 cents. A lipstick sells for 20 bucks. Which industry do you want to target? So we made our decision. And so we are now in the virtual makeover business. We sell this technology to a lot of beauty companies, and it's also for a lot of media companies as well. Now, what does this do? If you look at this before and after picture, the eye color has changed, the lipstick has changed, there is some eyeshadow, mascara, eyeliner, etc. There's some blush also, but it's difficult to see on the screen. This almost looks like Photoshop, but this is almost completely automatic. So you can literally upload a picture and click through and make choices. So the user is not thinking about, oh, how do I do the segmentation? They are thinking about which lipstick will I like? Now on that picture, these are the various features we have on our website. These are and each one of them, it's a different kind of rendering, which I'll tell a little bit about. Now, let me go through the process. What happens when a user uploads a picture? So after a user uploads a picture, we automatically detect where the eyes, nose, lips, etc. are located. And the first step is landmark detection. And I can't tell you exactly what algorithms we use, but there are a variety of algorithms that other people can use, and these are pretty decent now. We started with active appearance model, which a lot of you may be familiar with. And then there was this nice paper called supervised descent method, and now deep learning-based methods have literally crowded the market. So once the facial features are detected, these facial features are like corners of the mouth, corners of the eyes, etc. The next step is we do a head pose estimation, because depending on where the head is, the makeup would be applied differently. And we also do virtual glasses, so it's used for that as well. But the points on the face are not sufficient to apply makeup, because we want contours. We want exact segmentation of the lips, etc., so that we can apply makeup. So once the points are detected, we look at the gradients in the image, set up an optimization optimization problem, which is based on the image gradient and the detected landmarks, and estimate the contours. Some of our clients want quality estimation also. So we look at the photo, whether if the noise is very high, it's a webcam photo, or if the illumination is bad. In that case, we reject the photo. For application of foundation, we do skin detection. And in skin detection, it's useful because sometimes women have bangs falling on their forehead, and we don't want to color that region. So we detect the skin and eliminate, we color only the region where the skin is detected. And then we have this rendering pipeline. It's pretty complicated, so I won't get into the details. But one of the things that we regularly do is specular and diffuse separation, because when you color makeup, you should not be coloring the highlights. You should only be coloring the base. And then we combine those two things. And any makeup application we do has to be illumination preserving, which means that shading needs to be preserved. We also have this very cool application where women can upload their picture and change their hair color. And for that, you need to accurately segment the hair in the picture. And some of the techniques for this are Bayesian matting, Poisson matting. They all fall under this general category of segmentation problem, which is called natural image matting. It is, in principle, similar to green screen matting, but there is no green screen here. It's a natural image. And finally, for hair coloring, we transform the color distribution of one hair to another. Like when people say blonde color, it's really not a color. It's a distribution of colors. So if you want to change from blonde to red, the whole distribution needs to be changed. So we have some algorithms for that. Here's an example of how good the automatic facial feature detection works. I decided that it doesn't make any sense for me to tell the error rates, et cetera, but that because those numbers don't mean anything. So here, the before picture was uploaded, and the contours were not adjusted at all manually, and the after image was generated by applying makeup. So you can see that the lips, the contour are pretty much nailed. The eye contours are also really good, and the eyeballs, et cetera, also. So we do a really good job of estimating facial landmarks. We have this feature that I was talking about, changing the hair color. For that, we use interactive alpha matting. And interactive alpha matting is an application where the user puts a few dots around the hair. So the green dots, they suggest that this is hair, and the red ones suggest that that region is not hair. And with this very sparse information, we are able to get a very good segmentation of the hair. And this is not a binary segmentation. It's an alpha mat where it's a 0 to 1 segmentation. So you can see that the hair color was changed with just a few clicks. We also do virtual hairstyles, but this is not for e-commerce. People like InStyle use this for entertainment purposes. So our tool is also on InStyle.com, and we represent about 40% of the traffic. Now, with this virtual makeover technology, let me explain how we are affecting the e-commerce world. So this is how, if you go to any makeup site today or any retailer that sells makeup, you will see these beautiful images but of products. You have no idea what that product would look like on a person. So we suggested to them that won't it be more compelling if you showed it on a person. By the way, these images on the screen look terrible, but that's fine. So they agreed, and they said that, OK, we can do this using Photoshop, because they know that photographing models is really expensive, but they could Photoshop it. We said, well, what about this, that when you're selling a makeup product, you're not just selling one makeup product. Usually, you want to sell an entire look. You want to upsell. So you would like to combine different makeup items and create a look. How about that? And their answer was, we'll use Photoshop. OK. So we said, well, what about different models? But because people want to see their own skin tone, you will buy more if the person in the image, the model, looks like you, right? Then they started thinking. And we gave them this calculation. We said 10 models, 10 lipstick products, 10 eye products, 10 blush products. That's 1 million. That got them thinking. So now we have a bunch of customers. We have Macy's, Revlon, Neutrogena. And on most of these sites, the makeup rendering is live. On some sites like Amazon, they are doing a pilot. So we are not live yet. I mean, you may accidentally see the image, but it's not on 100% of the pages. Now the question is, does site commerce work? I mean, it's a compelling argument that it will work, but unless you see real-life data, you're not sure. So this is from one of our clients, and I can't mention which one, but it's again not very clear on the screen, but the revenue per visit went up by about 75%. The conversion rate went up by about 35%, and the average order value went up by about 25%. And this is an industry where we talk about 5% increase is huge. So this is transforming the beauty and fashion industry. Okay, so the next question we asked was, what can we do beyond makeup? It's very obvious. Some of the things are, why don't we do nails? So we did nails, and some of the problems in nails are actually easier because the 3D modeling of a nail it's actually pretty simple. And then you just have to know how to render these things. Virtual glasses, this is a very exciting project. We were very excited about it. We did a really good job on this, because if you look at the lens, if you just take a picture and try to apply it on a photo, it would look like plastic. The illumination, because of the illumination, it looks like plastic, because when light enters the lens, it bounces around a few times before it comes back to the camera. So the interaction with the skin of sunglasses is complex. We were very excited about this project until we knew that we came to know that there are about 3 players in this area who are just suing each other. So we decided to halt. We did virtual jewelry for Home Shopping Network. And in this case, the main problem was getting a very high quality alpha matte. Now, because we were in their shooting pipeline, we were able to produce a rig for them. The problem with this is that you cannot use a green screen. The normal technique would be that you use a transparent mannequin, put a green screen behind it, and boom, you get an alpha matte. But you cannot do that because a lot of jewelry is either transparent or it is reflective. Now, so the green cast is going to spoil the jewelry. So we set up a rig where we had a lighting setup. Some of the images that we took were backlit, and we were able to get a very high quality alpha matte. And this is completely automatic. The photographer had to spend something like 1 or 2 minutes per photo to generate these things. Virtual clothing, this is, again, very interesting. This is something which is our focus currently. The idea is very simple. You take models separate from the clothing, and you can mix and match. Because if you just take one photo, you're done. But if you combine them, you can create a whole, like 1 million images I was talking about. Not only that, you can also do virtual accessories. So take one photo of a model in a pose that we determine, and then you can accessorize the model. This could be used for upselling. So the second part, these are some of the things that we are currently working on. It is image-based recommendation. Like in the beginning of the talk, I said that recommendations are really good now, but the next step would be image-based recommendation. So if you think about Google, what do they try to do? When you're searching, they're trying to build a profile. They try to understand what kind of a person you are, what's your age, what's your location, what are your preferences. They are building a profile about you. And then they are able to recommend ads, right? Now, in our case, if you use photo analysis and add shopping data to it, it can be a really, really powerful recommendation engine. And here's how. When a user uploads a photo to our website, and we do photo analysis, we know their skin tone, we know their eye color, we know their lip color, we know their hair color, we know their ethnicity, face shape, and on and on and on. So that's scary, actually. But if used in the right way, this can be used for recommending them the right product. So you could say that 1,000 people with your skin tone and your eye color use this foundation, maybe you'll like it as well. So it opens up doors for collaborative filtering and and even the new machine learning, deep learning kind of applications. Apparel recommendation, and Baidu has already kind of cracked this problem. They have taken a stab at this problem already. They're doing a good job. And the idea is that you click a photo of a shirt, and you can find all the other shirts available on the internet that look like it. You could have a color-based search, or you could have a pattern-based search. So the one below, they are essentially check shirts. Now, that brings me to the end of the presentation. And here's a little wish list for people who might be wanting to help people working in the beauty industry. So what can we do? So like I said, that 80% of the images on the internet are human faces. And that is why cameras do have face detection. They do have blink detection and smile detection, et cetera. But you can take the idea a little further. Why not do landmark detection? Why not do skin detection? And there are other people who will build very cool applications on top of it. There's also this very interesting application area of color measurement. There is one and only one company that I know of which does color measurement, and that is X-Rite. And they came up with a product recently which can take a measurement of your skin, and you can use that for makeup recommendation. In fact, Sephora uses this product. But I guess people in this audience who are building these kind of systems can build some of these. And the final application is pattern classification and recognition, which there has been so much said about that topic that I don't think I need to elaborate on that. So that's about it.